Okay, I think we are ready. Hello and welcome to DevSecOn Canada virtual event, everybody. We are hosting this event together with DevSecOn community and Mobsquad. Talking a little bit about our community. So DevSecOn community is a global inclusive community that educates and enables developers in application security, whereas Mobsquad helps engineer who wants exciting roles in Canada, supporting companies across North America. We also got our amazing speaker, which is Danish and Hassan, which will be talking about supply chain attack, focused on NPM attacks specifically. But before we dive deeper into our session today, let me quickly introduce myself. My name is Dollis, and I am a senior customer success engineer in Nirmata, and I'll be your host for this event. Without wasting any of our time, let's get our session started. I would now give it to Danish and Hassan to introduce themselves and start the presentation. Please continue to drop all your comments in the comment section and we can take it for you. So,
Hello everyone. Welcome to today's DevSecCon session. And I'm Danish, and Hassan would be speaking with me on this presentation. We actually had done a research on some supply chain attacks on which we would be talking on today. Okay. And Hassan, can you please introduce yourself?
Yeah, thank you, Danish, and thank you, Doris, for having me in this event. This is Hassan, as you guys know my name. I'm a security engineer and I'm an HITB speaker as well. I have spoken in multiple conferences that include Black Hat and ThreadCon as well. And in this talk, we are going to talk about supply chain attacks, which is actually focused on NPM attacks. So yeah, that was a very short and quick intro. So Danish, let's get rolled today. To you.
Okay. So this is a little bit about me. If anyone want to connect with me on LinkedIn, they can just scan the QR code or can ask Dolis for my LinkedIn or stuff if you want to get connected or ask questions about this presentation or research after this presentation. I'm a security engineer and researcher. Uh, I have been a speaker at Black Hat and ThreadCon conferences in the past. I have been a moderator at OWASP 2022 Global AppSec conference as well, acknowledged and rewarded by companies like Microsoft, Apple, and Nokia for finding vulnerabilities. And I also train, cybersecurity stuff at HITV, and also done some CVs research in cybersecurity as well. So, just a little bit of a disclaimer that nothing in this presentation is meant to be illegal, malicious, or done in any unethical way. And we expect this from everyone that is going to listen to this. And all of this is for educational and research purposes to make this world a better place to maybe, you could say, live. If I, you know, uh, yeah. So first of all, actually, what is supply chain? Traditionally and generally, supply chain means the involvement or a network of suppliers, raw materials, and manufacturers to produce a specific final product, and then supply that to the final consumer. In traditional terms, supply chain involves people, entities, information, resources, and activities that, you know, collaboratively result in a final product, like in industries and stuff like that, right? If you think about a car industry or the car making manufacturing unit, different parts of that car would be coming from different parts of the world and different type of industries, whether it is a gearbox, whether it is a, you could say, a windshield, or other parts of the car. So not every part of the car would be manufacturing at the same unit. So just to give you an idea of how supply chain works, so let's take an example of this cuisine, this dessert from the Middle East. Uh, if you think about it, and if any one of you have ever, experienced it, it's a very delicious dessert. If you think about it, not only the cook or the chef created this delicacy. It involves dough, it involves cheese, it involves pistachios, it involves oil, honey, and stuff like that, So what if anything out of that, process or the objects that are used to make this dessert gets expired or gets bad, the final product or the consumer would get affected. So this is just to give you an background of how supply chain works, so that when we move to the digital supply chain or the supply chain in a digital world, just to give you a context, this is how supply chain works in the real world or in the traditional or general terminologies. So let's talk about software supply chain. Software supply chain actually means anything that goes into the code base until the application or the code actually made it to production. Different type of objects, different type of code snippets get into the code before making the application finalized. Whether we talk about dependencies, whether we talk about binaries or other packages. So let's see how software supply chain works. This is a general, you could say, representation of how it works. But as you can see, we are missing something here, and that is dependencies. And today's focus would be on the dependencies and how it can actually affect the security of the final product or the security of the final application or the any digital asset. So, as you may have heard a very famous proverb that chain is only as strong as its weakest link, and it would be very relevant as we move forward to the research or to the actual presentation that we have done. And if any one of you are thinking that we are going very, you could say, from very basic or from very basic perspective, but just to give you a reminder that this presentation is for everyone, right? So we can also expect that some of the beginners are also listening to. So just giving the context here in a better form. So this is just a meme that Okay. So talking about this software supply chain. So we would be talking about this part of the supply chain, dependencies. Security issues revolving around this part would be discussed today and would be highlighted shortly. Let's talk about the examples of the possibilities on how supply chain attacks could work, or the example of supply chain attacks specifically. First of all, the vulnerabilities, right? If we think about the vulnerabilities in the code that we are getting from the person or anywhere from the internet, we can think about the vulnerabilities that could be present in that code, right? Some of you may have heard about the very famous vulnerability in Log4j, or known as Log4Shell. So it was also possible because of the vulnerability in a dependency or from the third-party code that developers were using. And there is obviously nothing wrong with using the third-party code, but we should be vigilant. Let's talk about it later. Another example is typo squatting. Typo squatting is actually mimicking the name of a trustworthy package or dependencies to fool developers to trust a malicious one. Examples are given here. For example, the actual the dependencies could look like this, and malicious one could look like this. Just a little bit of moving around of uh, the dashes and symbols, and there could be a typo while developer is developing a code. There could be anything, maybe a keystroke is not working, right? So attacker can take an advantage of that scenario and create any similar naming convention of the dependencies and just put out any malicious code into it. Just an example, right? There is another example of supply chain attacks that are possible because of repo jacking. Attacker could claim repositories a username when an actual person changed the name of the repository, right? There could be account takeover. We would be talking about this specific attack vector a lot in this presentation. Account takeover is actually uh, uh, you know dependencies actually live on the registries, and registries could have the maintainers, and maintainers account do have the email addresses and stuff. So what if the account of that you could say maintainer gets attacked? That package could get get affected. Package maintainership could go into the bad hands, and a lot of other possibilities. And then we have dependency confusion. Uh, Recently, security researcher was able to, just to show an example, he was able to get into Microsoft, Uber, Apple, and Tesla by using this type of vulnerability. Okay. These are some of the examples on to show the impact or show the significance of supply chain attacks, or why they are relevant, why we are talking about this thing today, and why you are listening to this talk today. That uh, let's take an example of the first one, right? Uh, but in this example, uh, 500,000 systems were affected in SS because of the, uh, you could say, updated feature or updated dependencies which were being used. And let's take an example of Log4Shell. These are a lot of tech giants that were affected by Log4Shell. And Log4Shell is an example, a very good example of software supply chain attacks. These all of these companies were affected one or another way when Log4Shell was on a peak. So, okay, let's talk about NPM, Node Package Manager. NPM is the world largest software registry. Software registry is something, to put in a layman language, is something that stores the dependencies or third-party code so the developers can use it to just avoid the reinventing of the wheel, right? And why we chose NPM, or why we chose JavaScript packages or dependencies for these features? Because uh, for the last 9 years, JavaScript was the most commonly used programming language, uh, and uh, by this stats of Stack Overflow, around 64%, used language was JavaScript. That's why we chose it, and we would be uh, diving deep into it shortly. Okay, so talking about NPM, NPM do have packages of this sort. This is one of the very famous package called Express. These are the dependent. This is actually a screen snapshot from uh, NPM. So what do this mean? This means that Express is dependent on 31 different dependencies and 65,690 dependencies are depending on Express, right? So if you are depending on Express, you are eventually depending on 31 dependencies, and 65,000 dependencies are actually depending on Express. So till now, 270 versions are there, just to give you an example. Okay. So we did this research around a year ago. This Snapchat is from those days. So by then, there were 2.1 million packages which were living on NPM registry, you know, and these were the download numbers by the week, by the month. So you can get an idea of how much, on what scale this NPM registry is being used and dependencies are being used. Okay, 2.1 million packages, and these are the download numbers. Okay, this is just an example of express dependency that I recently showed, just to give you an example of how the chain or how the supply chain actually looks like in the real world, right? These are the dependencies of Express, and this is how it looks like, and containers, and just to give you an idea. Okay, moving forward. Okay, so have you ever thought that on NPM or the Node Package Manager as a registry, there are accounts of the maintainers that are actually maintaining those packages? What if that account get hacked? You know, uh, thinking about maintainer account getting hacked, there could be two possibilities. Let's talk about this. What if their email address are takeoverable? Uh, or what if their passwords are leaked in some breach, the passwords of the maintainer eventually, and then obviously the package can get breached, and there could be malicious uploads or updates to that package that could affect a lot of other applications, right? Eventually. Okay, so talking about that possibility. So package is maintained by maintainer, as already mentioned. Those maintainers could make changes and push out new updates. And then maintainer account is linked with an email address, right? Maintainer account of that maintainer that is on NPM is linked to an email address like a Facebook account, like a Twitter account, or anything like that, right? What if the domain of that email address is expired? Have you ever thought about that? For example, the commonly used the mailbox is Gmail. Most of the developers would be using like Danish at gmail.com or stuff like that. But what if obviously they are developers, maintainers are developers eventually who made the packages. There is a tendency of using their own domains as well. For example, contact at danish.com, right? What if the domain that I'm using, danish.com, is expired after a few years and I'm still using that email address on NPM? Just to give you a context, we would be diving deep into it. Okay. Okay. If the domain is expired of that email address, attacker could potentially take over the domain. Obviously, if the domain is expired, I can just go and buy it for $10, or if it is premium one, or attacker could buy it for $500, for example. By buying it again and then create a same email address. For example, attacker buying uh, contact@danish.com and then uh, creating a same email address, contact@danish.com, right? Now an attacker could take over an account of that maintainer, obviously. uh, you know what does that mean and what's the significance? Let's move to that. Okay. So last year, uh, there was a cybersecurity researcher who took over NPM account, which was a maintainer of a library with 6 million downloads a week. Okay. uh, by the methodology that I just shared, by using the expired domain, by using, by then claiming that maintainer email address, and then obviously uh, claiming the NPM account. Okay, and that NPM library had 6 million downloads a week. Okay, so how does that work? Uh, okay, so we took an example of a dependency or NPM package which had 36,000 dependent projects. Okay, so obviously, just to represent that to you, from a graphical presentation that I just shared, that package is obviously linked to a software registry, right? And that software registry account is linked to an email. And here's the maintainer. And obviously, email address is linked to a domain, right? What if that email address the domain of that email address gets expired, like in this example? Attacker could just simply buy that domain and then take over that email address, take over that software registry account, go to NPM, and then attacker would have access of that package, right? Okay, so this is just a text version of what I just said, or let's take a look at it. Attacker looks for the maintainers of a target package. Let's say there is a package XYZ. Attacker can look into the maintainers of that package, and we would be showing you how is that possible. And then attacker just take out the maintainer email addresses, and then by checking the whois data of all the domains of those email addresses of the maintainers, he can see what domains are expired, and then so on and so forth. And then use a forget password on the software registry and can just create a malicious update of a XYZ package, right? And uh, think about it. There would be hundred of thousands of applications that would be using a famous. Let's actually think about this one, right? Uh, the package which was being downloaded 6 million times a week. Think about the usage of that library. Let's take a rough number. It would have been used by, let's say, 100,000 applications at a time, because 6 million downloads a week is not a small number, right? Indirectly or directly, it would be used by maybe 100k applications, right? And now when attacker actually took over that package, uh, he could just create a new malicious update, and the malicious update can go into the code bases of a lot of applications, uh, unknowingly, you know, just by trusting the third party code anywhere on the internet with a lot of download numbers, right? Okay. So when this attack was happening, when these examples were coming out, I had a privilege of talking to the same blog, the register that I just shared the screenshot of, on how the, a developer can fix this problem, and how can it can be prevented on first hand. Okay. This supply chain attack. But that was the manual approach. That was the approach for the small applications. So we thought about the big applications. We thought about the bigger impact, and uh, we digged into it. Okay. Okay. So if we talked about manually, it is very simple actually. The developer or the application that is using NPM packaging can list down all the packages. It can be available in the log.json file. The guys who use JavaScript would know. List down all the packages that your company is using, or use the pre-organized list within your code base. Okay, and then it's a manual approach and a very dumb approach actually. So query each package for the below command. This command npm view package name here, and then the maintainers.email. Okay, uh, and it would just give you output of all the email addresses of the maintainers of that package. Okay, and then take the output of all the email addresses, copy that output, separate the email address, and separate the list of all the domains. Okay, uh, and then run who is data on all the domains, and you could find out if any domain is expired. Okay, third-party tool like email identifier from the bug data and email validators could be used to identify the expired domains of the packages that you are using in your code base, just to see the impact, or just to see what's going on from a manual perspective. But let's talk about the automated part of the things. Mostly hundreds of packages are used by a single organization, right? And it is preferable to repeat this on regular basis. Cron job could be implemented with this to keep your code base secure from this attack vector. And you know, and these were the motivation that there would be hundreds of packages being used by the bigger organizations, or maybe thousands of the packages. And these were the motivations behind sharing the automated script that we have over here. We can share the link with you if you guys want it for your usage. You can use this automated script and just put your file of the packages over here, and yeah, you can scan your packages for this specific attack vector, on how many of the maintainers are using spy domains and stuff like that, right? Uh, to make your application secure. So take an example of this one, that we were able to just put the list of uh, packages in the text file, and then it you know gave out the vulnerable domains out to it could be used in the CI/CD pipeline. Cron jobs could be used to automate it, and you guys could use it. If you want to automate that in your CI/CD pipeline, just take the screenshot of this link, or we can share this afterwards if anyone wants that. Okay, and then okay. Okay, so that was the automated part of how you can secure yourself from this tag vector locally or on your application, right? But we actually did a research. Uh, the motivation behind this research was to find out what's the security posture of packages in general worldwide, or the all the packages on NPM, you know, against this account takeover possibility. There are other possibilities of supply chain like vulnerabilities and a lot of stuff, but we were interested in this specific attack vector that we were looking into, that we were automating, that we were putting the blogs on. So we thought of doing the research on the worldwide level. So in this research, packages were collected from the publicly available resources online, and we made scripts, and we used a very high RAM and a very high power servers uh, to conduct this research. So Hassan would be showing the research that I was just talking about, that we did on more than 2 million packages, and how it was successful, and what we found out from that research. Hassan, please.
Sure. Can you guys hear me?
Yes.
Amazing. Thank you so much, Danish, for explaining and getting into all of the supply chain details. Now I'll take it from here. Uh, is my screen sharing working? Fine.
Yes, perfect.
Perfect. So, for those who didn't know about me, I am actually an OSCP. I have presented in multiple conferences that includes Black Hat, ThreadCon, and also in DevSecCon speaker as well. I'm an HITB speaker, and I'm being acknowledged by Google, Microsoft, and other companies as well. I love to perform at scale research, and I'm also traveling around the world. So yeah, this is me. So let's just dig deep into the research now. If anyone wants to connect to me on LinkedIn, feel free to connect. Okay, so first of all, this research is going to be two-way process. In first phase, we are going to extract, as Danish explained, there were actually 2.1 million NPM packages at that time. So in the first phase, we extracted 2.1 million npm packages from package manager. We extracted the email addresses as we have explained before. All of the packages are actually have email manager. We extracted the email addresses as we have explained before. All of the packages are actually have email addresses as a maintainer email. So from 2.1 million npm packages, we got about 6.7 million email addresses. And as you know, for example, if I work for Google, for example, xyz@google.com and abc@google.com, then when we strip out those email addresses, then we will get duplicate domains. So in this first part, we collected the packages and then we collected the email addresses. And then from these email addresses, we collected domains. But again, to extract those email addresses, we utilize a lot of high servers. We use a lot of methodologies and scripts for the extraction of email. Here you can see as an example is an API tool which is used by NPM, and then we used it to extract the email addresses. If anyone want to try this tool, there is a link attached in this slide. uh so as I was explaining, we extracted the unique email addresses from in the first phase, and then from these email addresses we've extracted unique emails, and these are the unique email addresses we have identified. And once we have those unique domains from these email addresses, we can come up with the number, which is 132k domains. So we are finally getting down into the research. We started with 2.1 million npm packages, and now we are down to 132k domains. This is just a graphical representation of all the process. As you can see, right now we are on the extracted domain section. Okay, so so uh, once we extracted all of these domains from the email addresses, initially we used npm packages, we come down to the number 675, which is expired domains. So you know, this research has a lot of limitations and a lot of problems, because there are rate limits and other problems in between, and you have to use parallel scenarios and multiple methodologies for the extraction and for the extraction of emails and extraction of domains as well. And shout out to my colleague Yev for helping me out in finding out these rate limitation problems and stuff. So this was the number. Please keep this number in mind, because we are going to use it in future slides. So multiple use queries has been used to extract, because to identify expired domain, you need to identify the expiry date of that domain. So we use multiple whois commands and multiple whois tools that we run into parallel for the extraction of these expired domains. So, as I have explained before, this research is going to be a two-way process. In first process, we extracted all of the emails from the packages. Then we extracted the domains, and from these domains, we extracted all of the expired domains. Now we are going back in the second phase, and in the second phase, we are going to attribute those domains with the email addresses. And then we did this, we finally came up with the number 845, uh, which is just domains, which is just email addresses. This is just a graphical representation of all of the process. As you can see, we started with the packages, then email addresses, and then we extracted the unique emails. And you can see the all of this whole process here. If we just divide the total extracted email addresses number with the unique email addresses, we get the number 11. Why this number is special? Because it tells us there could be 11, on an average 11 email addresses on a single npm packages, which could be the contributors. So this slide is very important. Please look into this. So in this slide, we actually identified only 25 email addresses, and the result is really eye-opening. As you can see, the packages on the right side, and then you can see the numbers. So 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 I extracted the domains, and you can see the number. So this is really eye-opening because you can literally see the domains and on how many email addresses they are actually relying on, uh, you can say. So just if we, for example, look at the first domain which I have redacted, we can see there are actually 3,800 something um, email addresses. So just imagine if this domain gets expired, then then attacker would be eventually able to hack into those email addresses. And okay, so this is another average that we identified. If we multiply by 11 packages that we initially extracted, extracted, and we multiply it by 845, we'll get the number 9,400 something, which means which are the actual vulnerable packages. So let's get down to the final steps of the research. As we can see, we started with the 2.1 million npm packages, and now we are down to the number like 2,800 packages which are actually found to be vulnerable. Yeah, this is actually a very small number because the packages were huge, but I will show you the impact in the next slide, how this is going to create a lot of impact. So right now, if we look into the impact slide, you can see the vulnerable packages were 2,800, but when we extracted the total dependent repos, we came up with the number to 257k dependent repos, which means there are 257k dependent repos actually are repositories which are actually dependent, and you have used those packages in their in their node manager file, which is package.json or stuff like that. As we can see, the dependents, which is 93k, which means there are actually 93k packages which are actually relying on these packages. And if we look into the fork, there are actually 400k plus forks of these packages. Now just imagine there are actually people, there are actually organizations, and they are just forking and cloning all of these packages into their repos. So just imagine there could be 400k, like multiple systems or people are actually being getting attacked or being vulnerable to this attack factor. And if we look into the contributors, we can see we have 50k plus contributors which are actually contributing in those packages. So the impact is really huge here. I know we started with the 2.1 million npm packages, but the number was small. But if we look into the real impact, we can see how it's actually impacting right now. Significance, if we look into the significance, more significance, we can see that in the previous slide, Danish has explained an NPM package can have multiple dependents. So if for example, if you talk about an Express package and it gets hacked, then there are multiple dependents of that package. So these packages are also going to be vulnerable. And people are also, a single package. In previous slide we have showed that like there was a 6 million downloads of that package which was hacked initially. So yeah, there is another representation. Let's just load this. So as you can see, we looked for the Express package here, and you can see all of the dependents. So this is huge. If one package gets hacked, it's going to affect other packages as well. Just like in the initial slides, we showed you the very famous cuisine kanafa. It was linked with the recipes, and just like npm package, it's literally linked with all of the dependents and dependencies of it. Okay, what other risk scenarios, what could happen more if that email address other than account takeover, what can happen more? As we know, there are actually breaches happening day by day. There are a lot of dark web leaks, Telegram leaks are coming day by day. So what if that email address and its credential it's being leaked somewhere? What can happen? So this is something, if we look into it, it's going to create a huge impact if we just look into those email addresses. So just imagine if that email address is being leaked in the dark web, leakage, and if that exposed credentials are being same as npm repository for their account, then it could be lead to straight account takeover of that package. Ruby gems research approach. So that was all it about npm. Out of curiosity, we did the same research, but we did something different in this one. In this Ruby gem research, we actually identified all of the, first of all, we extracted all of the Ruby gems. We use their main library, and we use multiple methodologies and tools, as you can see on the screen, to identify all of the gems. But on this research, we did something different. We didn't just extracted their maintainers email addresses. We went for the open source data. We extracted all of the, we scrap all of the GitHub, Bitbucket, GitLab, on other things we can scrap, and we extracted all of the gems that are being publicly used. And then we identified vulnerable gems. From vulnerable gems, I'm referring to those gems which are actually vulnerable to dependency confusion attack. Yep. So in this next step, we actually spin out 100 vps's, and then we created this backdoor, which is actually confusion gem.py, which I and Starcode has written. And thank you for Danish for helping me in this tool as well. So we did this research, we spin up vps's, and we set up this vulnerable Ruby gem, which can actually get the reverse shell and show us from where this request is coming from. And the most hard part of this research was to actually identify from where the request is coming from. And for this, we used the collaborator, burp suite collaborator, to explorate the data. In this slide, you can see we use burp, and then we extracted whatever information we can from the server. This is just a research. So we actually scanned like 1700 gems, and we found out that 285 gems were vulnerable at that time. And if we just look into the average, we can say 16% of the gem was vulnerable. So in the previous slide, I have showed you we extracted all of the gems, but in the research, we did not scan all of the gems. We just scanned which ones are actually publicly available in open source projects. And it was 16% found to be vulnerable. Here's another script for the dependency confusion if you guys want to check it out. It's very simple to run. You can just run the script and give it to the file or maybe the gem name, and it will tell you if the gem is actually vulnerable to dependency container or not. Okay, there's an other tool that I have coded. It's called gem scanner. If you give it gem file .log, and you will be able to identify which of the packages or the gems are actually using the older version, and then you can have them updated. Uh, okay, so let's get into the solutions. How we are going to tackle this problem, this account takeover problem, and how actually the NPM is actually helping the community to to sort out this problem. Initially, NPM has implemented two FA on 100 packages, and same goes for the RubyGem as well. They are also implementing the 2FA 2FA on their side, and now they are actively increasing the amount of 2FA on famous npm packages. What other solutions can help you with this? Third party tool, third party library, third party, anything which contains if you trust that piece of code, always proactively look into it. The best solution is to validate the checksum that you guys actually cloning the exact code or the official repo or anything like that. Use multiple automated tools like depend abort alert, perform regular security monitoring, and the third party audit should be involved in your security cycle. And here are some tools that could be used for the solution of this attack. As you can see, as I've initially mentioned, depend about alert. There's a GitLab security scanner, of course, npm audit and digest for node packages, and the bundler can be used for Ruby gems. And there are other WASP, and you can see the tools like bundler integrity, which actually looks for the checksum whenever you have third party code inside your system. Another thing which is actually getting inside market is SBOM solutions. So basically, SBOM solution looks for the third party packages that you are actually importing, and then they push automatic updates, and they create PRs and stuff like this to help you protect against this attack vector. Here's another third party, the SBOM solution that could be used to solve this problem. And recently, I was reading this article that SBOM has been made a requirement for the companies, for the SaaS companies, and it's actually being ordered by President no other than Joe Biden. So yeah, this is getting serious because recent attacks are actually more likely to happen through the third party instead of your own code. So yeah, SBOM is getting um, you know so that's it. That's everything from my side. If you guys have any questions, feel free to ask. Feel free to ask. Yeah. Getting back to dollars. If you have any other questions.
Perfect. Let me just get Danish on the stage as well. And let's take 1 second. I think we have no questions here. And Danish, Hassan, it was wonderful session. Thank you for your time to present to us this. And folks who are watching, thank you for all your time. I hope you enjoyed it. And meanwhile, next time until we meet soon, bye bye for now. Have a great day. Bye.
Thank
Bye bye.
you. Bye.